Hello everyone, I am Ümit Alkuş. In this video, we will solve one problem in chapter 11. Big Ben shown in the picture is a widely known tower clock in London. Its hour and minute hands have respective 60 kg and 100 kg masses and 2.7 meter and 4.5 meter lengths. Treating the hands as long uniform thin rods, calculate the total torque because of the hands' weights with respect to the rotation axis at 3:33 post meridian as in the figure. First of all, let us find angles alpha and beta. The angle corresponding to each hour can be depicted as follows. Now consider the hour hand. According to this figure, 3 hours corresponding to 90 degrees and 33 minutes corresponding to alpha degrees, from which we obtain alpha as 33 minutes over 3 times 60 minutes times 90 degrees. Therefore, alpha is found to be 16.5 degrees. According to the configuration for minute hand, we say that 15 minutes corresponds to 90 degrees and 12 minutes corresponds to beta degrees, from which we obtain beta as 12 over 15 times 90 degrees. If you calculate, you obtain beta as 72 degrees. Now let us find A and B. According to the configuration for the hour hand, we have A equals d over 2 cosine alpha. We put the numerical values into this equation. Thus we obtain A as 1.2944 meters, or approximately in 3 digits we have 1.29 meters. Also, for the configuration for the minute hand, we write B equals d over 2 times cosine beta. With the numerical values, we get 0.69529 meters, or in 3 digits it is approximately 0.695 meters. The definition of torque is tau O equals RO cross F, where tau O and RO are measured according to the rotation axis passing through point O. Definition of cross product gives us tau as R times F times sin theta, where theta is the angle between F and R. This is equal to R times sin theta times F. According to the figure, R times sin theta is the component of the position vector perpendicular to the line of extension of force F. Therefore, we write R perpendicular times F. By the same way, tau is R times F times sin theta, and according to the figure, F times sin theta is the component of force F perpendicular to the line of extension of position R. So we write tau as R times F perpendicular. The direction of the torque is found by the right-hand rule for the cross product R cross F. In this example, the direction of torque is into the screen. If we use three-dimensional XYZ coordinate axis, the torque is in the negative Z direction. So we write tau equals R perpendicular times F times negative K hat. where negative k hat is the unit vector in the negative z direction. Also, for this case, the direction of torque is towards u. According to the xyz coordinate system, we write torque as r perpendicular times f times k hat. Anyway, the torque because of the r hand with respect to the rotation axis is r perpendicular times f times negative k hat. Where r perpendicular is length a and f is m times g. So tau r becomes negative a times m times g k hat. Insert the numerical values into this formula. So we calculate the torque because of the r hand with respect to the rotation axis as 761.11 k hat in Newton meters. Because position has units of meters and force has units of newtons in SI unit system. Also, the torque because of the minute hand is r perpendicular times f times k hat. According to the figure, r perpendicular is b. And f is capital M times g. Therefore, tau minute becomes b times capital M times g times k hat. Now, we put the numerical values into this formula. As a result, we obtain the torque because of the minute hand as 681.38 k hat in Newton meters. Finally, the total torque because of the hand's weights with respect to the rotation axis at 3:33 p.m. is found by the formula tau total measured from O equals tau hour measured from O plus tau minute measured from O. We put the numerical values into this equation. As a result, we obtain the total torque as approximately negative 79.7 k hat Newton meters. Okay, this result brings us to the end of the discussion of this problem. Thank you for your attention. See you in the next video.